Hi, my name is Chiranjeevi. In this project, I have built a fully automated weather data pipeline using Docker, Apache Airflow, PostgreSQL, and Metabase. So this pipeline fetches real-time weather data for major UK cities using OpenWeatherMap API, processes that data using Apache Airflow, transforms and loads that data into PostgreSQL, and then finally visualizes the data using Metabase, which is an open source BI tool for beautiful visualizations, all within Docker. So the goal of this project is to get hands-on experience with modern data engineering tools and to build a real-world solution that handles data ingestion, data storage, and data visualization. So this entire infrastructure is built using Docker Compose, which makes it easy to set up, to deploy, to version, and to automate. So in this demo, I'll be going on through each of these components and will be explaining you each in detail. So let's dive in. We are in OpenWeather website and in current weather data section, where we'll have all information on how to make an API call, and this is the API call that we are going to make, so which have latitude and longitude position we can search using, and we need to provide our own API key here. We can get our own API key by either creating an account with OpenWeather, or if you already have an account, you can just sign in. And once you sign in, you need to go to top right hand corner and click on My API Keys. So once you click on it, you can see your API key, which you can copy and then paste it here to get the information regarding the latitude and longitude positions you want. So this website also provides information on how the JSON response that we get is going to look like. So it has the information such as whether it's going to rain, or like the temperature, visibility, speed of the wind, clouds, and sunrise, sunset information, etc. So out of all this information, we can use our code to only fetch the information that we need. So that's in the transformation process. So once you have set up your OpenWeather account and got your API key, we can then proceed and look at how we have set up our Docker Hub and Docker Compose. So let's go into that. So I have now opened Docker Desktop. You can see my project is already running. So this is how our project is going to look like in Docker. So here, these are all the services, all the separate containers running in a single Compose stack in Docker that is under Weather Pipeline project. So this one is for Airflow, this one is for Metabase, this one is for pgAdmin, which is a graphical user interface for querying SQL based queries on a Postgres database. So I'll be showing that here. I have had them open. So this is the Airflow. So it is running in localhost, that is on our own system. So this is how the DAG is going to look like, and you can see the audit logs once the DAG runs. You can see the audit logs here, and so once the data is fetched from the OpenWeather API, it's then loaded into database here using Airflow, and you can see the loaded data in Postgres. So this pgAdmin is a graphical user interface where you can see the we can connect it to Postgres database, and we can visually see the tables and query it from pgAdmin directly. Okay, and this data, once it's loaded, we can then use Metabase to visualize that data into some beautiful dashboards, however you look. So I'll be going on through all of these step by step. So this is our code, and this is the folder that we have all our code in. So the first file is the Docker Compose file, which is in the root folder, that is in the main folder. And we also have like other folders such as Airflow, DAGs, images, and Postgres. So the DAGs have the code, the Python related code of Airflow, and the Postgres have the SQL file to create a database at the start of Postgres. So this Docker Compose file, it is a YAML file, so it has all the services that we are going to run The first one is Postgres here, PostgreSQL till here, and it's followed by pgAdmin, which is a graphical user interface for querying Postgres database, and it's followed by Airflow service, and it's followed by Metabase service. And we have also defined volumes and networks to connect all these services together in a Docker. So let's go through each of them step by step. So for example, in Postgres, we are pulling Postgres image in here, and we are setting environment variables. For example, Postgres user and Postgres password. So for logging into Postgres database for the first time. And we are also setting up volumes to indicate where we are going to store this Postgres data and which file we need to run at the initialization of Postgres database. So this one, it's mentioned init.sql. So at the start, so once we create this Postgres database, we need to create a table so that we can load the whatever fetched data directly into the table. So once we run our Airflow, so this is the file that will run once the Postgres database gets created. So this is a create table. If you know SQL, you should already know about it. It's simple. It's just creating a table with columns ID, city, temperature, humidity, and weather description and date. So if we go to Docker Compose again, so we have defined port as 5432, which is the default port for Postgres. And so as you can see here, if I click here, so this is pgAdmin. It's not Postgres. Let's go into the code again. So pgAdmin, if you see, the port is 5050, and we can see that here this is 5050 port that it is opened on. So even in pgAdmin, we are pulling the image, setting up environment variables, assigning port, and mentioning that it depends on Postgres. So once Postgres loads, the pgAdmin container should load afterwards. And followed by this one is Airflow service, and we're also here assigning environment variables and defining how this service need to start and what it is depending on. So once the Postgres data loads, once the Postgres database gets created, we need to start the Airflow container as well. And these are all the environment variables. So we have defined it here because we don't want our environment variables to be exposed. So for example, if you see Postgres user is not directly, the username and password are not directly mentioned. So instead they are mentioned in environment variable here, which I'm not going to show you, but I can show you an example how that environment variable is going to look like. So this is how it's going to look like, which have like, we can mention our own passwords, and for Postgres database, Airflow, and we can even mention our API key in here, so that so once we are sharing this project onto GitHub, we can ignore, we can mention this environment file to be ignored at the time of uploading, because we don't want others to see our password. So if you go on to git ignore file, we have mentioned the environment file to be ignored at the time of uploading it to GitHub. Okay, so back to Docker Compose. So yeah, we have assigned the port 8080 here. You can see Docker, the Airflow 8080 port is active and it will be running there. And if you go on to the command, so this is the command that Airflow requires for the first time startup. And let's go to Metabase. So as the image, the port assigned is 3000. So and the Metabase opens in port 3000 here. Yep. And we have defined some volumes and for persistence, and shared the Airflow net for the shared Docker network in here. So for all these containers to communicate with each other, we have defined the Airflow network, which is a shared network. So once we load all the Docker Compose YAML file, you can see this code by going on to the GitHub repository that I'll mention in the link below. You can see that you can copy and paste it in your own code, and you can just follow the folder structure that I mentioned here. You need to create all these folders, and you need to have the Docker Compose in the root file in order to run this properly. let's go to terminal here, bash. So let's kill down all the existing process that I already have in here so that I can start fresh. So I'll go on here, the code. So once I once I write docker compose down, all these containers will be stopped and removed. So we'll start from fresh. So docker compose down. So we are also removing whatever volumes or the data that we already have in those volumes. All containers are removed now. You can go to Docker Hub and we can see there are no more containers left in here. Under Postgres folder, we need to create init.sql file. So yeah, once you do that, just go create a weather.etl.py file under dags folder and paste this code which is available in GitHub. So I'll explain this code step by step. So we are just importing various libraries for our code to work, obviously. And the first variable that we define is the API key, so that we can use the if you remember that previously that I mentioned the API call in OpenWeather website on how to make an API call. So this is what we use in our code in here under the fetch weather function. So this is where we use our API key and load it in here. So yeah, so I have used os.getEnv function to fetch my OpenWeather API key, which is stored in my environment file in here. So yeah, and next I have made a list of 10 UK cities with their latitude and longitude positions, which we'll be using them to fetch all these cities information. So the next one is the fetch weather function that we define to fetch data from the URL that we mentioned and load that response JSON and take only the information that we need, the fields such as city, temperature, humidity, description, and date. So from that API response, so these are the only fields that we fetch from that, and we'll load this data into our database. So this fetch weather function will be called in the store weather function, which we will see from now. So this is a function to connect to PostgreSQL and to store the weather data after fetching. So once we fetch the data, we need to store that into PostgreSQL. So this connects to PostgreSQL database using user and password. And yeah, so this has a for loop which iterates through each city by latitude and longitude and fetches that data and stores it into PostgreSQL database in here. Yeah, so we'll define DAG, which has the DAG ID, DAG schedule interval, which will run this schedule every day, and we'll put default args as default args. And now in here we are defining store weather task, which will call Python operator, because the code that we wrote here is a Python code, so that's why we use Python operator, so that we say Airflow that use Python operator to understand the code above and to call the store weather function which we defined above. And this is the store weather task. So if you go to Airflow in here and go to graph, we can see that's the only function. Okay, now we have closed the Docker container, we can't see it anymore, but once we run it, we can see that. Okay, so once you load Docker compose YAML file, the weather ETL py file, and your environment variable, and once you copy and paste it in init.sql. So once you are ready, just go to your terminal. You can either go to bash or like command prompts. I'm just trying to run bash in my terminal, so I'll type docker compose up build. So this will read the YAML file that we have here and run all the services that we mentioned in here. Okay, so now if it's for the first time, it'll take some time because it needs to download all these services into your local system and to create containers for them. So if you already have them, it won't take much time, not more than like one or 2 minutes. Okay, So we will wait till all of these Docker containers are set up. So parallelly you can see what are all being created. So now these are all created again, and the ports are assigned to them. So you can just click on this and it will open that for us. Yeah, as you can see, everything is loaded, and we can just go ahead and refresh the page in here. So as I said earlier, I have defined my username and password in .env file. So based on what you gave, you need to give that same username and password. So I'll give them now. And so yeah, so this is our DAGs that we have. This is the weather ETL DAG. So it's successfully loaded in here. Just need to toggle on this one, and the first time it will run automatically. Now the green bar you can see says that it's running, and yeah, so it says success. Now you can go to the graph and click on this, go to logs. There you can see the logs where it's success or failed. So it says it's fetched the weather data for London city, the response that we got from the API, and it successfully inserted the weather for London into our database. So in order to view the database, we need to either go to PostgreSQL, or as we already have pgAdmin. If you want to query that data in PostgreSQL, you can do that in terminal itself, but I'm going to do that in pgAdmin. So for pgAdmin, my port is 5050. So I'll go to localhost 5050. I'll just refresh the page. So I gave the email address as admin@admin.com and the password. Yeah. So as this is the first time we are setting up pgAdmin, we need to connect it to our Postgres database. So you just need to go to servers and click on register and register server. So give the name of our Postgres database, that is WeatherDB. So that is the name I gave. You can give whatever name you want, and go to connection. The host name that we want to connect to is Postgres, and they just give the username and password you gave for Postgres. So again, you can see that in the environment file. You can go back and check what password you have given and what username you have given. You just need to enter that, not the one I'm giving. Okay, I've given Airflow. Okay, so now I have successfully connected to Postgres database, and you need to go to WeatherDB here and click on database drop down. There you can see WeatherDB database. Click on the drop down, go to schemas and go to tables and click on weather. Right click on it and click on query tool. So now you can write a query to load the data from the database. Okay, so now I'll do select everything from weather table. Okay, so now if I run, yeah, so as the Airflow DAG ran successfully, the data got loaded. So this is the current real-time data of all these cities. So the London city is having temperature of 12 degrees now, 12, 13, 14, 12, 14, 9, 13. So it's average of around 13, 12 to 13. Yeah, and the humidity, this is humidity, weather description and date. Yeah, it's successfully loaded. So that's perfect. And next what we need to do is to visualize this data somehow. So we'll use Metabase, which is an open source BI tool. So for Metabase, we gave port as 3000. So you just need to go to the link, localhost 3000. So we already have it open here. So this is the visualization that I created previously. Once I refresh it, this will be gone because I have removed all the volumes as well. So I'll refresh it. So yeah, so this is the first page that you see once we open Metabase. It didn't have any information that I created till now, so it's starting from again. So So let's get started. Select your language, click next, give you a name. Okay. It's not necessary to give working emails. It just takes whatever you give. Okay, just company name, create your password. Yep, strong. Yep. So select whatever you will use Metabase for. Just select the first option. Next, add your data. So now we have our data in PostgreSQL database. So we'll select Postgres, and you can write whatever display name you want. So I'll just write weather ETL underscore DB. So that's the display name. The host name will be Postgres. Okay, the port will be default, that is 5432. That is for Postgres. If you go and see here, for Postgres we gave the port as 5432. So there's the thing we need to give in here. Oops. In here, the database name is WeatherDB. That's the one we have created in here, and the username will be, what did I give it? I don't remember. Airflow. Yeah. Again, so the username and password you give to the Postgres database should be entered here, not the ones I gave here. So I have given Airflow and Airflow as the username and password. So yeah. So once you do all that, just connect database, and once it connects to database, it gives the success message. And if you want to allow Metabase to anonymously connect your usage, click on that. Otherwise, just toggle it back and click on finish, and we are all set up. So click on take me to Metabase. So this is the home page of Metabase. So we can see our analytics, we can see our databases. It's a really wonderful tool to visualize our data. It's really good. It's very easy. There is not much learning curve to it. So the first time if you are going there, just go to new databases, and you'll see our weather ETL database that is connected here. Click on here and go down, scroll down, and you'll find weather table here. So these are all the tables, and in this weather table we can see our loaded. So this is the information that we already have in our pgAdmin that we queried. So you can see that information in here. It's really nice. So yeah, we can visualize this data into however we want. So click on new. If you want to create a new dashboard or a visualization, just click on new. So the visualizations will be in the form of questions. So if you want a visualization, you just need to click on a question. Otherwise, you can also click on a new dashboard, give it a name, UK weather data, weather. Yeah, and description if you can give, it's optional, create. So yeah, our dashboard is created. So we can add a chart now. So to add a chart, click on add chart and click on new question, or you can also give SQL query, whichever is okay for you. So click on new question and select the database that you need to ask this question from. So I'll select the weather ETL and click on weather table in here. So it will select the weather table, and we can here filter, or we can join data. These are all the functions that we have. Our data is not like that big of a table, so I'll try to create few visualizations based on the available data. So it's just for today. So once the DAG runs every day, the data will be populated accordingly, and we can then do averages or whatever visualizations we want. So in summarize, just click on pick a function, click on average of. So if we want average of temperatures across all cities. We can click on this one and we can group them by cities. So click on city, so it will find average temperature by each city by grouping them by city. So at the moment we only have like distinct values of all cities, but yeah, we'll see that information. So once you click on that and click on visualize, so yeah, this is the data we have. If you don't like purple color, you can also change that. So this is the, if you go down here, so this is a graph view and this is the table view. So this is what we got, average of temperature, and this is the graph view of it. So if you click on visualization, you can change the look and feel of the visualization. You can change it to line graph, you can change it to area graph, or whatever, whichever you feel comfortable. Okay, so if you go on settings, we can click on it, we can change color, and we can also change how this looks. Can click on access if you don't want access to be shown. For example, for y-axis, I don't want the label to be shown. Yeah, this is how it is. And if you go back, click on done, it'll be done. Otherwise, if you're on like any other, it'll show that. If you don't like the sharp lines, you can also smooth it out. Once click on that, click done, and go to settings and click on the three dots in here. You will see the styles of it. You can click on line shape to be a little smoother, you can click on it to be step, you can click on it to dash, whatever, whichever is comfortable to you. Yeah, and we can click on the line size, however you feel comfortable. So yeah, I'm happy with this one. So we can go to formatting as well, we can select a style, we can have it as percentages and so and so, and click on done, click on access. For example, if you want to show values, let me see if you can show values on data points. So now it will show the values now here. I'm happy with this one. Okay, so once you're happy with the visualization, click on save and give it a name. So what did we do? We took average of temperature by city. So city, average temperature by city, it's the name of this visualization. Click on save, and there you go, your visualization is ready on the dashboard. We can resize it as to whatever size we want, whichever size, so it will get adjusted dynamically. So yeah, so once this is done, we'll click, if you want to add one more chart, click on here and new question. So before adding new question, you need to save the changes of dashboard. So click on save changes. So we'll click the weather data and summarize the average of, let's go with humidity now, by city, visualize, go to visualization, click on row. Are you okay with this? I'll go here, pie chart, yeah, bar chart, click on done, click here, change color, and yeah, you can go to style, you can go to formatting, whichever you prefer. You can go to display, you can show the values, and if you don't want y-axis like me, just click on that, and I don't even want x-axis now. X-axis. So once I'm satisfied with this, I'm done, and I'll click on save. I'll click average humidity by city and click on save. This is the average humidity by city information. Yep, this is how we set the graph. We can move it in here and here, anywhere we want, whichever you feel comfortable doing. So now I'll try to add one more. Let's go with a new question, save before it, weather, pick a function. I'll select the number of cities that we have, distinct values of city. Okay, there are 10 cities. Okay, number of cities. Yeah, I'll save that. Here, the number of cities. And if you want to give a heading, you can also give that heading. You already have that in the dashboard, but yeah, of course. UK visualization. Once you click on that, we can also move that to the top, whichever you feel comfortable. So let's go. And let's add one more of these. New question. Pick a function. Now let's go to the average of again. Let's go to temperature by city. There is not much information to experiment with here. Visualize. I'll try to create one more chart. Let's go pivot table. Nope. Combo, scatter. Oh, this looks fancy. Let's see. Waterfall. I don't know if it makes sense, but yeah, this looks fancy. Yep. Let's save this. Average temperature by city. I'll save it, and here we go. These are all our visualizations. As you can see, we went from fetching the data from OpenWeather. We used a DAG on Airflow to extract the data and transform it and load it into our database. And we loaded it to our database and queried it. The data looks fine, and if we want to visualize it, we visualized it using Metabase BI tool, which is really handy and really easy to use, I would say. So yeah, this is the end-to-end project. I hope you liked the video till now, and if you have any comments regarding this or any clarifications, just post down a comment and I'll try to answer as much as I can. Okay, so if you want to view all the code related to this project, I'll put my GitHub link below. You can go there and check out all the codes and just read the README file. You'll be good to go. Okay, and thanks for watching till now. I hope you like this video, and see you in the next video.